So, radical equations. Yesterday we did just kind of one radical, or like I said before we started recording, the radicals would just cancel off for you. Today it's going to take a little bit more space, so we're just going to start moving some of this stuff out of the way. One of the suggestions I gave you yesterday was to isolate the radical, correct? Because you normally only had one. Well, today it's going to be isolate a radical. Okay, you get to pick which one you want to isolate, but I would strongly recommend getting at least one of them by itself. You don't have to, but it speeds up the process, which is a long enough process already. In this setup, are either one of my radicals all by themselves? No. So you got to move one. Doesn't matter which one, but I remember all the trouble we had with that thing yesterday. It'd be a good idea to probably get rid of that. So let's just add that entire radical over to the other side, because negatives can cause some issues. So just add the entire thing to the other side. So then I have to add it over here as well. So the end result is the square root of 3x plus 4 equals, because these just flat out cancel. Now that 3 that's kind of sitting there all by itself, that one, can I put that inside the radical or not? Unfortunately, you can't. So I have isolated a radical. Now something that I wrote down in yesterday's notes becomes hugely important. Remember, whatever you do to one side of an equation, you have to do to the other side. Like right there, I added a square root to one side, I added it to the other side. It just happened that I couldn't combine the terms, so they stayed separate. Well, if I'm going to square this side, can I just square whichever term I want over there? No, I have to square, unfortunately, the whole thing. Okay, I squared the left side, gotta square the right side. And you know that. That's how algebra works. The best part is this side where it cancels. It's 3x plus 4. Now you can maybe see why we isolate a radical. Imagine having to square that where it starts at the beginning. Squaring with two radicals in it, you try and avoid that as much as possible. You can't always, but it takes some work. Squaring the 3 would have been easy, but so equals. Now we have to do this. Well, what it really means is to take that times itself. Right? And so to do that, we have to basically flip. So let's take 3 times 3, 9. But I also have to take this 3 times that. And how do you multiply like that? Can I put the 3 inside the radical or not? No, it just has to stay out front. So plus 3 square root of 2x minus 7. Are there any questions on how I distributed that blue 3 with the green arrow? No? Well, we have a blue square root of 2x minus 7 that we also have to distribute. So let's take that times 3. So basically I have another one of those. Now this is the one that normally causes the most difficulty for people. I have to now take the square root of 2x minus 7 times the square root of 2x minus 7. In other words, I'm taking it times itself, right? So I'm really just squaring it, right? So I have a square root and a square. What really happens there? Yeah, they kind of cancel, right? And so really it's just that. Because I took it times itself, so I squared it. So the square and the square root cancel. So any questions on that last one? Or any of the distributing that I did? And have I taken all the pieces times each other that I'm supposed to? Yep. So now what we have to do is clean it up. Well, here we've got a 3x plus 4 equals, can we put the 9 and the negative 7 together? Yeah, what is that? 2. How about these? I just put a squiggle underneath. Can I combine those? Can I combine it with the 2x as well? No. But this radical matches that radical. Here I have 3 square root of 2 minus 7s. Here I have another 3 square root of 2 minus 7. So how many of them do I have? I have 6 square root of 2x minus 7s plus 2x. And I don't like how this looks like division, so I'm going to get rid of it. Well, that was a lot of work to still have a lot of x's in the problem. But how many radicals did we start with? 2. How many do we have now? Oh, so this turns into what you did yesterday. There's only one, so get the radical by itself. We only have 1 now. So let's do it. This 2 right here, it's got to go. Subtract 2. Because I'm running out of space, is it okay with you if I also subtract the 2x kind of at this same level here and not make another step? Because I'm kind of running out of room, okay? So I'm going to subtract 2x at the same time. Everybody good? So it's 3x minus 2x. X. 4 minus 2 is plus 2 equals 2 minus 2, gone. I still have that. And I still have that. Whenever you have a number out front of your radical like this 6, it's your choice. You can divide both sides by 6 if you want. But then we have x plus 2 over 6. Not sure that's the way we want to look at that, is it? Probably not. So I would say let's try and take care of that radical right now. And what's the only thing that's going to take care of that? That's a square root, right? So the only thing that's going to take care of that is if I square, but remember you can only square each side. So I'm going to square this side. Yeah, I'm going to square that side. And I'm running out of room. All right. I'm going to move it up here for you. Is it okay with you? Well, here, let's square the right side. Let's square the right side. 6 squared is 36. And what is the square root of 2x minus 7 squared? Yeah. 2x minus 7. Can I go back now? No. I didn't think so. There we go. Is it okay with you if I just square x plus 2 for you? It would be foiling. I think we can all do that. Can I just square that for you and save time? It would be x squared plus 4x plus 4. Hey, wait a minute. How many radicals did we start with? How many do we have now? Oh. How about that? Are there some questions back there? No? Okay. Well, what are we going to do now? Distribute 36? That's probably a pretty good idea, huh? All right. So x squared plus 4x plus 4 equals 72x minus, what is it? 252? Yep. Yeah, that's right. Well, now what? We got all these radicals. We got rid of those at least. Well, now what? I see an x squared. Is it going to be going anywhere? Is it going to cancel out algebraically in any way? So you're telling me I have something that's quadratic? So now we'll go over this way. X squared. How about we get it to equal 0? So let's subtract 72x from both sides. Can I add the 252 at the same step, or am I going to lose people? We good? No? Yes? Plus 252, and I'll add 252 right here. So what is negative 72 plus 4? Negative 68. X It's a positive 4 and a positive 256 or 252 equals. Now, believe it or not, that actually does key number factor, but I don't know how many of you are going to just tell me the numbers that multiply to be 256 and add to be negative 68. Nice.
12 and 11, really?
Yeah, I'm thinking 12 and 11, maybe no. So, what's your other option? Quadratic. Oh, 64 and what? No, that multiplies to be negative 256.
64 and 4. I told you it was 64.
That adds to be 68. Oh, negative 64 and negative 4. There we go. All right. Now, what if you couldn't come up with those? Quadratic. Yeah, you got to do quadratic formula. But here we go. So it becomes x squared minus 64x minus 4x plus 256 equals 0. Or again, there is a 1 out front, so you can take the shortcut if you know it. Are you ready? That was missed yesterday by somebody, or the other day. X minus 64. What has to get out of there? Negative 4. So your factors are x minus 4, x minus 64, and let's not forget this is supposed to equal 0. This is nothing. We're getting 2. So set this one equal to 0. You get x equals? That equals 0. But what was that called yesterday? You can get wrong answers, or what's the technical term for that? Extraneous. Now what we have to do is make sure they work. Well, sometimes that does happen. You do all this work and it's no solution. So, how about this half of the room here, you substitute in 4, see if it works. This half of the room over here, substitute in 64, see if it works. I think it might be on my desk. Well, I've just done 4 to see if it works. Okay, what'd you find out about 4? 4 works. All right. What'd you find out about 64? Works. All right. So yes, all that worked for 2 answers, but at least they both work. Check. They work. Now, your attention right back here. Yeah, there was quite a few steps there. Was any one step overly difficult? Not really. Were there a lot of them, though? Yeah, that's the key. So what was the initial problem? There was radicals. We didn't want them. So we had to get rid of at least one of them. So we got it by itself. We squared to get rid of it. Unfortunately, we did have to FOIL on this side. It got kind of long. We combined stuff. And then we only had one radical, so we had to get rid of that one. So we got rid of the radical. Just so you know, this does not always happen. You do not always end up with something quadratic. Sometimes, very nicely, the x squareds cancel off and are gone, and it is simple algebra. Okay. I chose one that took some extra work. Okay. Obviously, if you don't find the key numbers, it does take a little bit longer because you have to use quadratic formula. But Chapter 4 deals with quadratic. The whole emphasis of Chapter 4 is about quadratic and what types of problems it can help you solve. Okay. Now, you're going to help me through the one that's not even here. Hmm? 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 Oh, well, I'll just write it down. All right. What would be a good initial step? Now, you can square both sides right now if you want. Yeah, let's get one of the radicals by itself. Does it matter which one? No. Did it matter on the last problem which one? No. So you just pick one. Let's say we don't like this one. We'll move it. So basically we have that. Now what? Square both sides. Very good. Make sure we're paying attention. We're on about the third step, and some of you haven't written anything down. Now, if you get better at squaring things, this could take you a whole lot less time. Actually, one of mine would do that, yes. No, it's not that one. I don't leave my personal ones out for your use. Yeah, the one that does algebra would have that done in a second. No. 4 times 4? 16. Now be careful. A lot of people do that one wrong, and they do all this work and get the wrong answer. The last one here in black. Negative 4. We're at 2n plus 3. What's the part that most people actually get wrong? The negative. Okay. Any questions where those two came from? Okay, now I have to take this times 4. And if they don't mess up the first one, they mess up the second one. It is a negative square root of 2n plus 3 times 4. So negative. And the last one is a negative times a negative, so that's okay, right? There's no big deal there. And so it's positive, and it's the square root of 2n plus 3 times itself, and so it's just the 2n plus 3. Once again, we started with how many radicals? 2. We're now down to, well, it looks like we still have 2, but in a second we won't. So here, 2n minus 5 equals. Can I combine the 16 with anything? 3, which is 19. Very good, whoever said minus 8 times the square root of 2n plus 3, because some people try and add the radicals. Right, you just leave the radical there and add the number out front. Plus 2n. Those of you that can look ahead see something very nice that's going to happen. The n's cancel, which means I won't have to FOIL on the left side, which means we won't have an x squared, which means we don't have to do, oh, look at all this wonderful thing. And let's subtract the 19 while we're at it. 2n minus 2n. Gone. Negative 24 equals negative 8. Cancels. Now, earlier, I told you that at this step, whenever there's a number here, it's your choice of whether you want to divide. I think we had a 6 and an x plus 2, right? That was a horrible choice. How about this time?
Yeah, it's a good choice.
It's a good choice. Should I take the negative as well? Might as well, right, while you're doing it. Do you have to do this? No, but if you don't, you're squaring 24 and squaring 8. So it's probably a good idea. Well, what number do I have here? 3, right? Equals square root of 2n plus 3. Square them. And no FOIL on this side, which is wonderful. Equals. Like 3. How come I haven't circled it yet? Oh, I haven't checked it. 2 times 3 is 6 minus 5 is square root of 1 is, I remember that, 1. This is, what are we putting in, 3? 2 times 3 is, plus 3 is, square root of that is, plus the 1 we already had is 4. Oh, hey, all right. Are there any questions? No? All right.